think I can already share some interesting information with you. First of all, of course, I would like to thank the organizers of this session, our collaborators from Chula University, who have organized that. It is part of our joint project funded by the UK Royal Academy of Engineering. So on this first slide, you can see who I am. I am Professor Sergey Mikhalovsky, and right now my main job is the Research and Development Director and co-founder of the company which we call ANAMAD. It is located in Brighton, where I live. And today I will be sharing with you my experience with these first steps. We'll hope it will be useful for you. If you would like to ask questions, I think the best thing will be if you raise your hand, so I can see your question, or you can send it or you can text it your question. And depending on the question, I will either interrupt the lecture and answer the question, or I will leave the questions till the end of the lecture. So anyway, this is the lecture about how I started my own business. And this is the case study of our company, ANAMAD. The ANAMAD is an acronym for the very long name of the company, Advanced Nanostructured Materials Design and Consultancy. The full title of the company, the full name of the company, reflects the expertise of its two founders, who are myself and my postdoctoral researcher, Dr. Matt Ilsley, who will be giving his lecture, I think, next Wednesday. Some background, very brief explanation where I came from, who am I, and so on. I am from Ukraine originally. I did my master's degree at the #1 university in Ukraine, Shevchenko University. Then I defended my PhD in the Ukrainian Academy of Sciences. And since 1994, I moved to the UK, where I worked at the University of Brighton. And I retired from this university in 2018 as a professor of materials chemistry. And then we started immediately in 2018 a small company together with my former postdoctoral researcher, Dr. Matt Ilsley. So he is a specialist in biology and biomaterials. I'm specialist more in chemistry and materials. So the first question everybody will ask him or herself: why do you want to do your own business? Well, here are my answers, because this is what I thought when I decided I want to do my own business. First of all, I wanted to become independent. When you work at a company or a university, and the university actually is also a very big company. In such a big place, there is always somebody above you, one boss, two bosses, 10 bosses, and everybody tells you what to do. And very often they tell you what to do is wrong. And because of that, you feel that you really, at some point, want to become completely independent. So if you start your own business, you definitely become independent. But of course, it comes with risks. First of all, financial risks. How are you going to survive if you start your own work independently? Because somehow you have to pay yourself salary. In this case, fortunately, because I reached the age of retirement, so I already secured some pension in the UK. Plus, when I was leaving the university, they paid me lump sum for the retirement. So I had some money saved, which means I was not dependent on the income from the company. I could survive without that income. Plus, I also had some additional work on the side. I was invited as a consultant for the American organization CDC. You may know this acronym. CDC is Center for Disease Control, which actually is the main organization in the UK, in the USA, which deals with COVID pandemic. But at that time, it was no COVID, so it was just a collaboration with this center. Then I still thought that I have enough energy to do some useful work. So I don't want to sit on the sofa. I didn't want to watch the telly all the day. I wanted to have fun. And for me, having fun is doing some work, so doing some research. So you can have fun in many ways, but for me, working in research is the best fun. That's why I chose a research career through my life. So, and I was successful. So why shouldn't I continue? And of course, you don't want to start business without thinking about making money. So this was also my hope that one day we'll reach that level when we will be able to generate money and not, if not be rich, but at least to be able to pay ourselves a decent salary. Also, that's another reason why an academic wants to do business. In academic world, your research is more or less limited to the laboratory walls, restricted to your laboratory. So your horizon is mostly based on deepening your knowledge of science, which is useful, which is important, which is interesting. But I always wanted to see the practical results of my science. And of course, if you do business, this is where you may get practical results. So that was another incentive for me to start my own business. Now, I have a question to you. Please try to answer this question, maybe by sending a text message or even saying loud your answer, although not all together at the same time. So this is the question. What percentage of startup companies fails? So my company was a startup. And here are three answers from which you can choose. 30% fail, 65% fail, or 90% fail. What's your answer? Somebody give me the answer. I see chat. Okay. So I think probably this is where, right. Answer 90%, 90%, 90%, 90%, 90%, 90%. Wow. You know what? I am very impressed because you are right. It is 90% companies which fail. So what it means is that you are very well aware of the risks associated with doing your own business. That's a good start because you should be prepared that you might fail. However, we still want to try. Why not? We take our chances, we take our risks. Otherwise, if we don't take risk, the humans will never leave their trees and will still live on the trees and eat bananas rather than do something else. Now, then the next question. What is the biggest reason why startups fail? There are about 10 different reasons which are suggested by the experts in industry. I just chose the top 4 reasons. The top 4 reasons why the startups may fail. But each of these 4 reasons have a different weight, different percentage. You might want to also tell me, Rosa says, haha, about a comment that 90% fail. So you might want to think which, in your opinion, is the biggest reason why the companies fail. And here is the answer. Surprisingly, maybe, but the biggest reason is that nobody wants the product which you want to make. I was surprised too. Before, when I just started business, later on, when I learned more about business, I understood why it is the main reason. And there are 3 other very big reasons. You can see the percentage of failure because of one of these reasons is between 20 and 30%. So please remember that, because when you want to start your own business, you need to consider all these potential reasons for failure and try to make sure that you mitigate these reasons, you mitigate these risks. Now, so having looked at these, again, starting conditions, we started thinking with math. First of all, money. We can run out of money, true, but on the other hand, we had some money to spare. We had some money to start the business. And so we were not desperate for salary. Plus, at that time, both of us, Matt and I, we had some job on the side that we could afford doing that job being paid money from that job and still developing our business. The second reason, not the right team. That actually is a serious thing, because if you bring the team which begins to quarrel, which begins to argue, hate each other, then of course it's a failure. Well, in our case, it was only two of us, myself and my postdoc, ex-postdoc Matt, and we already worked together for good 10 years. We knew each other very well. We went through difficult situations, we went through good situations, and in all cases, we believe that we can trust each other. So that was fine. Now, no one wanted the product. That's a very tricky situation. So you have to ask yourself what kind of product you want to make. Obviously, coming from academic background, we wanted to make some sort of research-intensive product, research-rich project. And relying on our previous academic expertise, we decided that we want to make materials for medical applications, because this was one of our expertise. And we want to make materials for environment application, because that's another expertise which we had between us. And then the fourth question, too much competition. So that means that before you even start thinking about the product, you need to also think where you can put this product on the market, where you have less competition. So you really need to do a lot of preparatory work. You need to look at the market. Once you decide in which direction you want to go, you need to analyze this market and understand where you might have lesser competition and then better chance for success. And this is actually a very famous picture. This picture was designed by the European Commission for Research Funding, in which they explain why when you start your business, you need to seek funding from other sources, for example, from the government, ideally. Let's look at this diagram. On the left, you start from the laboratory work, where you create new knowledge. This is still laboratory work. It may be part of your PhD project, it may be part of your master project, but anyway, it is laboratory work. No risk. You just do research which is funded by the government, by the stipend, maybe even by your own parents. But nevertheless, it is low risk work because you do this research. So this first phase of a product development is science. However, once you did science and suddenly, or maybe not suddenly, but gradually you begin to understand that you may develop something useful, which can be of interest to many people beyond the laboratory where you work, this is the time when you can start thinking about commercialization, about going into business. So you need then to transfer, to elevate this research from scientific laboratory to technological research, which means you need to explore the technology which you will then use to develop a product. And the question is, who is going to fund that? And the answer is, nobody wants to fund this. Why? Because it is still very early in the product development. And although there are many businessmen or many capitalists who have lots of money, but they will not be willing to give you this money because they are not sure how risky it is. You know, everybody who invests in you wants to have something in return, preferably profit. And at this early stage, technological research, they are very far from having any confidence in you, which is fair enough. So then, let's say here, this is the good time to start looking for funding from outside. In Britain, we have the governmental fund called Innovate UK, which specifically funds research related to commercialization. In Europe, the program called Horizon Europe now started just this year. They also have calls which are aimed at funding technological research, aimed at helping companies to develop new products. It's very competitive, but nevertheless, it is possible to get funding from there. Let's say you manage to get this funding, you manage to test your technology, but it is still not enough to start looking for venture capitalists who would give you money, because you need to design a product which will be called a demonstrator, and the phase, the development is called demonstrator phase, which means that you tested the technology, you know that it should work. Now you need to build this prototype, this demonstrator, which you can then show to potential investors. How you can show it? Well, you can participate in exhibitions. You can participate at scientific conferences where you show your stand with your product. You can go online. You can advertise your product here and there. So somehow you can attract attention to your product, but you still need to make it. And again, it is still a very early stage for somebody to invest money in you. So that's why you still need to try to seek funding from the government, from European Union. In our case, it is possible for Britain, although Britain left the European Union, but we can apply for European funding, including commercialization. And only then, after you manage to pass this so-called the valley of death, this is where all the companies go bankrupt, they cease to exist, they run out of money and so on. However, once you manage to reach this stage, where you already showed your product, demonstrated it to different potential customers, and they begin to feel that there is something in it, so they can start investing in this. That's when you can attract private funding. And this is how most companies develop. You can either go for the bank loan, which may be risky, or you can go for the private funding. These people are used to be called venture capitalists. For some reason, the word capitalist doesn't sound very good. So these days, these people are called business angels, which sounds much better, although it still means the same people who have money and want to make profit and invest in those ventures which can give them profit. So this is what I explained in the previous, about the previous slide. This slide simply repeats what I said. I would say you should choose a bank loan only if you believe that you can really very quickly develop a product and start making money. Otherwise, taking a bank loan is very risky. You may get very seriously in debt, and that, of course, creates a lot of trouble, which you don't want to have. This is another slide which I want you to be familiar with. This is a classification of the different degrees of technology development. This classification was created by the American Space Agency, NASA. And you can see there are 9 levels of technology readiness level. Each of them, we effectively went through them in previous slides. You start from the basic technology research, which will be somewhere TRL 1 and 2. Then you move towards demonstration, which will be up to TRL 6. And then once you get to TRL 7, 8, 9, this is where the business angels will be very likely happy to give you money. But until then, you still need to apply for funding from somewhere. Maybe you can even get money from your parents if they believe in you. But anyway, you have to start thinking about where you can get this sort of money before. What kind of direction you can consider for your business? I would say that especially for developing countries like Thailand, it is quite logical to consider one of these very well-known United Nations Sustainable Development Goals, SDGs. Here I show you the 17 SDGs which were thought about and were designed by the United Nations, in which they want to be involved, in which they want people to work, because they address some very important issues for the quality of life, for the economic development, prosperity, and so on. So you can see here these 17 goals, and you probably can see that 2 of these goals, number 3 and number 6, I circled with a red circle, or rather red square. Why? Because these were the 2 SDGs which we decided we want to focus on. Why? Well, first of all, as I said, we have expertise in medical materials, which addresses the SDG 3 about health. And secondly, we may develop materials for environmental protection, water treatment, and so on, which directly addresses SDG 6. So these are the two SDGs we chose for ourselves. There may be some others, but again, you cannot go immediately in all directions, so you need to focus on one or two directions. The next question is SDG 6. Why I mentioned here Ukraine, because Ukraine is also an example of a developing country like Thailand. Plus, you may know that we work together with Chulalongkorn University on two projects, both focused on water treatment. So the water treatment is a very useful direction to address the SDG 6. Now, which of those two is better to choose? Well, actually, one thing important is that if we can make clean water, then we also partially address SDG 3, because clean water is relevant to good health. But which one to choose? Here is just a more detailed description of what constitutes the SDG 6. Achieve universal and equitable access to safe and drinking water for all, increase the proportion of population using purified water, and so on and so forth. And also, importantly, improve water quality by reducing pollution. And we can make materials, and on this basis, we can make technologies, we think, which will help to do that. So SDG 6 definitely looks very attractive, particularly because there are new challenges in the water treatment. This is just a list of several classes of substances which have been flagged as dangerous, as detrimental to health and to the environment in just recent 10-15 years. So in other words, we humans did not know that these substances are pollutants and they could be dangerous to health. But unfortunately, you know, the more we know, the more we understand that this was not a correct assumption. And these substances can really have a harmful effect on the environment and health as well. So that means that plus, if you look at this text below the list of these substances, the American list of toxic substances already has more than 41,000 such substances. And every year, about 1,500 new substances are introduced into industry. There is no way, it is not possible to test all these substances, whether they're poisonous, whether they're toxic, harmful, harmless, or not. It's simply not possible. Because to do that, you really need to invest a lot of money. So what we decided is we will try to design a technology which hopefully can address all these substances together without asking a question, are they harmful or not? We'll just try to remove it. And how we decided we can do it, we focused on a very interesting technology which is called non-thermal or cold plasma treatment of water. Let me explain. And here is an example. So we applied and got funding for this work from the Innovate UK, which is the British funding body. You can see the statistics. 155 applications were submitted. 1/5 of them was funded, and our project was one of them. And this was the only one project which dealt with the Eastern Europe. This is our project, which shows this number one. Other projects were mostly related to Asia and Africa. And also you can see that there were quite a number of proposals submitted to SDG 6, but also there were other SDGs addressed. This is the official summary of our proposal, which was released to the press once the project was approved for funding. So we said that we will focus on Ukraine. Why Ukraine? For two reasons. First of all, I am originally from Ukraine, so I know very well the situation in this country. Secondly, Ukraine is one of the poorest countries in Europe in terms of fresh water supply. It's 32nd out of 40 European countries. And almost 30% of its population do not have central water supply, which means centralized water supply, which means that nobody knows really what the quality of water is. So we, and this was also a requirement of the competition. A British partner should work with a partner from the third country. So we went for this work with Ukraine. And the main decision was based, of course, on the fact that the cold plasma technology was developed by our Ukrainian colleagues. So that all came together. So the competition was two phases. Phase one, discovery. Discovery means that we need to test the feasibility of this project. We need to test the feasibility of the technology, whether it will work or not. Because of the feasibility stage, we receive relatively small money, but if it works, we're invited to the next phase where we already develop the technology to the demonstrator level that, remember, I told you, TRL 6, after which we can take off, start attracting money from investors and develop the business. And this was our first meeting, the kickoff meeting. You might see here Rosa just in front of all of us, because Rosa is our star or starling, if you prefer this word. And oddly enough, we had this meeting 10 days before the pandemic lockdown went into action. So we are lucky that we managed to have this kickoff meeting in Ukraine. And here we have several people from the UK, Professor Andy Kandi, Dr. Rosa Busquets, and myself. And these are our Ukrainian counterparts. So who are participants in this project? UK team, obviously, our company, ANAMAD. Plus, we have external consultants, academic researchers from the University of Southampton, Andy Kandi and Dr. Rosa Busquets from Kingston. Both of them have useful expertise for this project because they deal with analysis of water, water treatment, and so on. The Ukrainian team comprised the academic partner, the spin-off company, which in principle would make the device once it is ready for manufacturing. Plus, we had medical external consultants, epidemiologists, who work on the link between the environmental pollution and the human health. This is obviously very important. Now, it is probably interesting to understand how we met each other. And here, you know, everybody has their own history. For example, myself and the director of this spin-off company, many years ago when we were young students, we went together to the whitewater sports in Siberia, going down the rivers, all that stuff, because these were quite tough trips and sometimes dangerous. We know each other very well, and you know, once you work together in a dangerous situation, and you can trust each other. So one important thing is that when you start collaborating with other partners, you have trust. With Andy and Rosa, we work together at different times in the academic world in the University of Brighton, and we keep our contacts after that. So anyway, we knew that these are the people on whom we can rely. We know that we can trust each other, which makes a very good start for the project team. Now, very few words about the process of cold plasma itself. Very few, because obviously today the focus of my presentation is not on the technology itself, but on the path towards industrial commercialization. So basically, cold plasma is not very different in terms of its generation from high temperature plasma. You need to have two electrodes. You need to have a very high voltage between the two. And at some point at high voltage, there is a breakthrough the medium, whether it is water, whether it is vacuum. So there will be a discharge of electricity which generates plasma. You can see here At the bottom, a few pictures which show how this plasma is generated between the two electrodes. Why it is called cold plasma? Because it is generated in water. So anyway, it means the temperature there cannot go above the boiling point of water. But in reality, it is much lower. It is between 25 35 Celsius. So it means it is relatively convenient to work with it. And we started working despite the pandemic lockdown. So we organized this work very carefully. People obviously worked in the laboratory wearing masks. They tried, not always were able to, but they tried to keep safe distance. And more importantly, they tried to avoid using public transport. So one of them who drives a car picks up others and so on. And that's how we managed to work. And we worked through all the project time through the pandemic, because effectively the project started on the day when the pandemic lockdown started. So this was the laboratory design of the system in which we had this cold plasma. And we tested it for different pollutants. And here are a few examples which explain why we believe that cold plasma could be useful. This is a graph which shows how quickly the chloroform disappears from the water when you treat water with cold plasma. The baseline, which is the maximum allowable concentration here. So the concentration, we spiked water with the chloroform, which was many times higher than the permitted concentration. And you can see that in less than 8 minutes, chloroform disappeared and completely destroyed. It was completely destroyed, and it went well below the maximum allowable or even detection limit. Now this is quite impressive, because think about the efficiency of other methods of treatment. Chloroform is a tough pollutant to remove. That's why it is considered to be. That's why we chose it to demonstrate that the technology works. And we managed to do that. Another example, this is actually a tribute to the COVID. We decided to show that cold plasma can destroy bacteria and viruses. So in this case, we chose the E. coli. These are the bacteria which are officially used for testing the technology efficiency, because you shouldn't have E. coli in water if it is treated properly. These are just two different methods of analysis. The difference is the color difference is based on the color of the nutrients in which these bacteria grow. So what you do is you have the Petri dish in which you have the medium in which the bacteria grow, and then you simply count the number of bacteria which grow there at certain time. And you can see that on the left you have lots of bacteria, in the center less, and on the right you have practically no bacteria at all. And this is the graph which confirms that. So in less than 3 to 7 minutes, the concentration or the number of bacteria dropped down to practically zero, which is exactly what it should be. And although we tested it only with E. coli because it is a standard testing bacterium, however, understanding the physics and chemistry of the cold plasma, we believe that it will be the same way to destroy and remove all the bacteria and viruses in water anyway. So again, as we discussed before the lecture, if you apply for funding about COVID, you will definitely get funded. So if you apply for funding and say cold plasma will COVID in water, we probably will get it funded, but we didn't, simply because our aim was higher. We wanted to treat water from other substances, not just viruses or bacteria. Here is another interesting example. It also shows the glowing reactor of cold plasma. Actually, video will be nice, but I'm always reluctant to show videos because I'm not sure how compatible the video will be with the presentation. Anyway, these are just photos of the plasma reactor. And we put enormous amount of DDT. You know, DDT is a agrochemical which is forbidden for use in modern agriculture, but it was very widely used in 1960s and even 70s. And it is so inert that it still stays in the soil and is gradually washed out into the groundwater, into the fresh water, and it is considered to be dangerous. So what we did is we put enormous concentration of DDT in water, 7.8 grams per liter. Well, you'll never have that high concentration, of course. And yet, after 10 minutes, we managed to reduce its concentration about 100 times, which again convinces us that this technology is worth our attention. Then, once we did these preliminary tests, we tried to summarize the advantages of this technology because we need to define the niche for our product. So, and this is the list of potential advantages of the technology compared to other technologies. It is novel, it is original, it has low capital costs, it has low running costs because it practically does not need any chemicals. It doesn't need spare parts and consumables. This cold plasma works without any chemicals. It generates chemicals inside the plasma chamber, that's all. Should remove viruses and bacteria, which not every other technology can do, which definitely should remove organic pollutants, regardless of their composition, which again is an advantage because other technologies may not be able to do that, and so on. And we even did some estimates of the costs of such treatment, and we found that it is our estimates, of course. We still need to do it properly once we have the demonstrator, full-scale demonstrator, then we can estimate these costs a bit more accurately. But in any case, we consider that our technology will allow making fresh water at a much lower cost than even the second lowest cost technology, which is adding chemicals. Usually these days, the most popular method is reverse osmosis. Now, if you look at the previous slide, this is the second column, reverse osmosis. So reverse osmosis has quite high cost of water purification, 7.8 euros per cubic meter. So of course, if we can achieve the same result, but with this kind of cost, we should have a very competitive product. So what then? Once we convinced ourselves, because the most difficult thing is to convince yourself that what you're doing is useful. After that, you really need to forget for a moment about technology and research. You need to switch to writing the business exploitation plan, describe your business case, explore the market to be able to understand how much money it will cost you to develop this product, how much money you can make from it, and how quick. Plus, of course, what this analysis of the market means. You need to understand who are your nearest competitors. They may be existing competitors, or maybe some other team created a new company which also offers something very useful and competitive. And of course, you need to defend and protect your new knowledge with a patent. Intellectual property rights should be protected. And the most common way of protecting them is filing the patent application. Then, of course, you need to estimate the potential impact of your technology. And the potential impact means that how many people will benefit from that, and try to convert this benefit in the monetary terms. Because money is the main driver of any business. So if you say, oh, 10,000 people will live better, it is less convincing than if you say 10,000 people will live better and spend, say, 10,000 pounds per year less. So once you start talking about money, this is the language which business understands. Then they can think about how much money they can invest in you. And of course, you need to make sure that your product becomes known to everybody. So this all brings us to the next step of the product development, which we did not know much about when we started our company. This is called human-centered design. There are different approaches to the human-centered design and human-centered research. Here I just give the names of the most popular human-centered design approaches. They are named after the team which initially created this approach. They are more or less going through the same phases of development. But the most important thing is to make sure that you understand why you put the human-centered research in the center of your product development. Not the product itself, but the humans who will be willing to buy your product. So this is the very important emphasis. Not the product, because normally you think, oh, I have to develop my product, I know how to do it, this is what I'm going to do. No, because if you remember, one of the biggest reasons for the failure is nobody wants your product. So before you decide what kind of product to design, you need to talk to people in order to understand what they really want. And this is a very important element, and it is a paradigm shift in the mentality of the academics who want to become businessmen. So technology is a supply, but people define the demand. If you cannot convince people that they need it, and how can you convince them? You ask them what they need and try to explain that your product will address their needs. This is how you will be able to achieve that. For example, a couple of examples. A need for clean water does not mean that everybody will be buying water filters, right? So you may decide, oh, I want people to have clean water, and they want it, so I'll make filters for them. And people say, well, it's expensive, or they say, oh, I will do it the other way, or I will just buy bottled water, for example. Or a need to go to the gym does not mean that you will be buying a gym membership, or you will be buying an expensive piece of gym equipment and put it at home. So this is always about understanding the behavior of the consumers. This is about understanding their cultural perceptions and what they really want. This is just a slide. I wouldn't go into details of that slide. I will simply say that human-centered design is not a one-off process. It is a long process. It's a marathon which goes throughout all the phases of your product development. Because every now and then you will find that one group of customers whom you thought will be interested, they are not. On the other hand, you may find another group of customers whom you didn't expect to be interested, they will, and so on and so on. And that's why it is a very, very slow, very painstaking process, but this is what you need to do. And moreover, remember that your assumptions about need assume nothing. Do not think for customers, because they will think very differently. Plus, what is important is you do not offer a product to customers. You offer a solution to the problems which the customers have. But to do that, you need to understand what their problems are. So you see, that's why it is all about focusing on the end user and customer. So we identified the gap and demand in the market in Ukraine. Again, I'm not going into the details of that because you have a presentation, you can read that and understand it better. But this is a very interesting thing. Imagine that when we started the human-centered research, this slide, this template was empty. And by the time when we are finishing the project, we filled it with different information bits and pieces, because this is what we are doing throughout the project development. Not just making a product, but talking to people, understanding their needs, finding the potential customers, identifying the best customers, and so on and so forth. And then from that, you can design an action plan, what you actually are going to do, the business plan. We created, of course, a website in English and Ukrainian, on which we put this information. Plus, the website was very useful for us because it was, remember, the time of pandemic. So we couldn't go to customers directly because it was a lockdown. We had to approach them via our website, calling them on the phone, sometimes very rarely meeting them because it was not possible very easily to do under the restrictions of the COVID, and so on. So we had actually quite successful feedback from the people, customers who answered our questionnaire online. I show here only very few answers, but these answers were very informative for us. First of all, the question, does the quality of drinking water concern you or not? And to our big relief, we saw that 78% said yes, and 20% said to some extent. So very few people said it doesn't bother them. That means that if we can deliver the better quality of water, that should be interesting for many customers. The next question is, does the quality of drinking water affect your health? And again, to our big relief, we found that 98% think yes, it does, which means that, you know, once you are concerned about your health, and health is the most precious thing a human can have, especially health of their children, grandchildren, that means that you will be more keen, customers will be more keen to consider this technology. This answer was kind of guessed, because about 1/3 of people live in rural areas and they do not have access to the centralized water. And this is what we were figuring out, that we will probably first go to the customers who live in rural areas, because they may need to purify their water directly, because they don't have access to centralized water supply, and so on and so forth. Many people said that they think additional treatment will be the best solution to improving the quality of drinking water, almost 50%. All that helped us to understand, to become more confident. And look at this. Do you use purified drinking water? 2/3 say yes, which means that one way or another they try to do. So if we can offer a product which will help them and they see it as a better solution to their problem, we may win the game. After that, once we talked to the people, once we called them, once we met them, if it was possible, we created a matrix of potential customers. So our best target customers are in this square one, because they have money and they also have the high need in the clean water. The second group are also could be among our first customers, because they have high funds, high money, good money, but they may not have such a desperate need. And of course, we put in square 3 and 4 those group of customers which will not be our first priority, simply because it will be difficult to make money doing business with them for different reasons, mainly because they don't have enough monetary power. So who can do this project? Of course, scientists, engineers, designers are needed to make the products design. But we also need a lot of people who understand how to analyze market, business, and we need human-centered research and design. And we were kindly offered these experts by the funding body. So this is a conceptual design of our commercial prototype, which was based on the feedback from the customers. They told us that they probably would need 3 different sizes of this product, depending on their needs. And this is how we came up with this suggestion that will be 3 scales. And even more importantly, customers suggested, why can you make a mobile unit? We said, why do you need a mobile unit? The answer was, well, look, if you can have a mobile unit, you can bring your device to some places where temporarily there may be some disaster nature, maybe flooding. So suddenly the quality of water drops. It will be extremely expensive, if possible at all, to try to install some special purification system. But if you can make it mobile and bring it like a van, that will definitely solve the problem. So this concept, this idea of mobile system was suggested by the customers. We didn't think about that initially. And so what we are doing now, we have applied for more funding. We hope that we'll get this additional funding to cross the valley of death. We also got some funding for different processes which can be launched using cold plasma. And basically, this is the almost the final slides. What are your big ideas? Do you want to do commercialization or not? And what is your ambition? Are you thinking about doing micro business, which is a small company, less than 10 employees, small or medium enterprise, which is up to 200 people, or large enterprise over 250 people? And this nice creature on the left, you know, it is a unicorn. Little children, for some reason, are very happy about playing with this. But unicorn in business has a different meaning. What is a unicorn in business? These are four answers, and the correct answer is number B. The unicorn is a company which is worth at least $1 billion. So maybe you can think big and go for a unicorn company. And this is probably the last question. What is the vast majority of companies in the UK, USA, Europe, and I'm sure the same will be about Thailand? Do you think the majority of companies are unicorns, large enterprises, or micro business and small enterprises? What do you think? Right, okay, I think you want to finish my presentation, so I'll give you the answer now. Micro. So small companies are the driver of the industry, not large companies, not unicorns, but small companies, i.e. you, me, our friends with whom we create companies. We are the engine of the society development. And I would like to thank at the end of my presentation, first of all, the funding body, which is the Royal Academy of Engineering in the UK, and with who funded our two projects together with Chulalongkorn University, whose team leader and project coordinator is Dr. Nataporn Tonanon. We thank the Innovate UK for their funding of our project. And I also thank my colleagues who allowed me to use some of their slides in my presentations. That's it. Thank you for your attention. I finished. If I don't know whether you have time to ask questions, but please do if you want. Or if you cannot think of questions now, you may think about them later. You can pass them to me through Natamon or Natapor, and I'll answer them. Thank you for your attention. Dead silence. Are you thinking about your big ideas?
Hi, Sergey.
Hi.
Sri here. So, hi. So it was a nice presentation. It's good to see you after a long time. I have a question to you. So, is there any chance of incorporating the desalination process into this cold plasma method, which can be a better option of purifying the salt water from the sea? Is there any chance, or is there any possibility that you have to think about it?
You know what, your question is very timely, because initially we thought that cold plasma will be useless for desalination at all, because of the physical process involved. But recently, because everybody asks this question, we started thinking about whether it may be of any use in the desalination process, and we think it may. Not desalination itself, because obviously cold plasma cannot remove potassium, sodium, and these are probably better removed, of course, by reverse osmosis. However, reverse osmosis uses very expensive membranes, and they get clogged very quickly. So you need to replace them. You need to, so it pushes the expenses of the desalination higher and higher. We believe that we can combine cold plasma, use it in this case as a pre-treatment, which will allow reverse osmosis to be used more focused, just dealing with the ions rather than all the other organic matters which may be in the solution and so on. We only started thinking about that. I cannot say that we did our economic estimates of this, but at least I can tell you that why your question is timely, because we are beginning to change our mind about the possibility of using cold plasma for desalination. Thank you for your question.
Great.
If you are interested in that, we may still try to do it together through our, discuss that through our Royal Academy project. Because
yeah, of course, that's why I've asked, like, because most of the institutes and universities in India, they're interested in the desalination process, because we are surrounded with all three sides with ocean, and still we have places where there is a lot of water scarcity for especially for the potable water. So if there is a possibility of incorporating this desalination process along with this cold plasma, then that would be a very
you know what? We have to do it together. We have to think about this together. Yeah.
Sure,
so I'll be quite happy. This is one of the. This is another useful outcome of such meetings, such sessions, because we use it as a platform for exchanging ideas and developing the process and working together. So I'm very happy about this question. Thank you.
No, it's my pleasure. Thank you.
Right, I see somebody in the chat said, right, SME, yes, I have. Okay, yeah, so I answered these questions, fine. So at the moment, I don't have any more questions in the chat. I don't see you asking any questions. Of course, had I been physically present in front of you, I would squeeze these questions out of you, but unfortunately, because of COVID, I can't do it. So you're safe. You can stay without me squeezing you and asking questions and asking me questions. But as I say, I'll be very happy, because I believe what is particularly important about Chulalongkorn team, you are engineers, and engineering solutions are definitely useful here, which we can think about, develop. And again, you see, if you think about, we did this project with Ukraine. Why? Because the condition was one country only. But because we believe that this technology may be used in many countries and in Thailand as well, plus you have very good engineers, we might think about a lot of interesting technical solutions. Of course, based on the needs of the customers, not on what we think they need. Well, if there are no questions, thank you very much. And I'm delighted to see you. So many nice, young and healthy faces and optimistic. You are smiling, you are not sad, which means COVID will beat COVID. Stay safe.
Thank you very much.
Thank you. Bye.
Bye.